EMCH 362. This is the fluid lab, as you know. In this lab, we are going to establish a relationship between the fluid flow rate and the pressure difference. So we have explained the system that we have. So here, you see this is the fluid system. We have a reservoir here. The system starts with the reservoir, and there are two pipes here. You see the bottom one is the line which goes to the pump. So this is the inlet to the pump. And after adding energy to the fluid, the water comes out of the pump. So this is the outlet line. And in this outlet line, the water first goes through this paddle wheel, and then it goes through the mechanical valve, and then finally it comes out of this venturi tube. So there are three pressure sensors, one across the venturi, the second one across the valve. You see here, this is the pressure sensor, and the third one across the pump. So we get pump differential pressure from this sensor, we get a valve differential pressure, and also we get a venturi differential pressure here. So here we have two flow measuring device. One is the paddle wheel, and other one is the venturi. From these two flow measuring device, we get volume flow rate. So one volume flow rate from the paddle wheel, second volume flow rate from the venturi. We will also take a actual flow rate, which we will take manually with this measuring cup. And finally, we will also take power meter reading in watt from this watt meter. So we have a software here. This software can give you the paddle wheel flow rate, venturi flow rate, venturi differential pressure, valve differential pressure, and pump differential pressure. So we will follow the steps that we have derived last time, which are here. You see, we will turn on the pump, we will select the valve position, we will take the actual flow rate, we will calibrate the software, we will take the paddle wheel flow rate, venturi DP, valve DP, pump DP, power meter reading. After that, we will change the valve position and we will repeat step 1 to 4 for 5 times. Once we are done with our baseline design, which is a D/D ratio of the venturi about 0.5, we'll change the venturi and we'll repeat step 1 to 5 one more time. So first, let's start the pump and take the actual flow rate, and we will fill up a data table I have already designed for you. So this is the data table. We will fill up all those things. So here we will go for like 5, we'll take 5 set of data. 1, 2, 3, 4, 5. So let's start the system, and we'll turn on the pump, we'll select the valve position, and we'll take the actual flow rate. Here you will see that we have a mechanical valve. By changing the position of this mechanical valve, we will change the fluid flow rate. So we will start all the way from the open position to all the way to the closed position. Right now the valve is all the way to the open position. You see, when you turn the valve in counterclockwise, it goes to the open position. Now it is stuck in the open position. So if we turn it clockwise, it will close, all right? So let's make it all the way to the open position and turn on the pump. So we have fluid flow here. We need to take the actual flow rate. So the actual flow rate means we will collect the fluid for a certain amount of time, and when you divide the collected fluid with the time, that will give you the flow rate. As I told you, this is a volume flow rate, so we will collect the volume flow rate. Let's first turn on the stopwatch. Okay, now we'll start the stopwatch. 1, 2, 3. So our collected time is 3.93 here. So in 3.93 seconds, we have collected 700 milliliter. So this scale, this cup has a scale of in milliliter. So we have collected 700 milliliter. So 700 milliliter over 3.93 second will give you milliliter per second. So let's plug in this number here. 700 over 3.93. So this will give you 178.12 milliliter per second. But when we want to work with our software, we need to collect or we need to convert this data in gallon per minute. So let's multiply this number with 0.016. So this will give us a fluid flow rate in gallon per minute. So right now we got a actual flow rate and which is 2.85 gallon per minute. Second, we need to calibrate the software and we need to take all the data. So how to calibrate the software? To calibrate the software, we need to turn off the pump and tell the system that that is the 0 point. For example, if we turn off the pump, we can see that there is no flow here, meaning we have a zero venturi flow rate. So this is its 0 point. There is no valve differential pressure right now. So once we click this 0, you see these red buttons turn into green. That means this box is calibrated. Now we plug in this number here, 2.85. Now we'll turn on the pump, we'll hit start and then set. We will also take a picture when the system is ready so that we can capture the system data. We hit start and then set. We are waiting for the data. Okay. So what I captured here that I want to provide in this table. So you see that the first data we got from the pedal to it is 2.83. 2.83. The venturi we got 2.9. The pump DP we got 1.34. The valve DP we got 0.20. And the venturi we got 16.87. We also need to take the power. So we see here the power is 22.1. So it is 22.1 watts. That's it. So this is the first set of data. So we will go for the second set of data. So to get the second set of data, we turn on the pump. We need to adjust the valve position. So we need to make a change in the fluid flow rate so that we can have a data which is very different than the first set of data. So let's change the valve position. I gave 1 full turn. This is 2 full turns. I have some water here. Put them back. I already gave 2 full turns. Let's give 1 more half turn. And we need to see whether the fluid flow rate has changed or not. How can we get that? we can get that data from the power consumption. As you see here, it is still 21.8 or 21.8, 21.9. That means there is not much change in the power consumption. So what we'll do, we will go one more. Quarter turn. One more quarter turn. Yes, now we can see that there is a change in the power consumption. To make sure this power consumption value, we turn off the pump and we turn back on. And you wait for the power consumption reading here. Yes, it is 21.4. It means that the system has a change in fluid flow rate. Now we need to calibrate the system one more time. So whenever we change the valve position, we need to calibrate the system. To calibrate, we first need to exit or restart the software while the pump is shut down. Now we turn back on this software. We make this flow 0 dp. All right, but there is a problem right now. We don't have the actual flow rate. So once we change the valve position, we need to take the actual flow rate. So we close this software. We need to take the actual flow rate. So that's why what we need. We turn back on the pump, and then we take our stopwatch. We take the data. It's 5.43. So I see here it is about 835 milliliter. So if I go into this Excel, so what I need to do, so 835, so 835 over, the time is 5.43 seconds. So this will give us the milliliter per second, and we multiply this number with 0.016. It gives us 2.46 gallon per minute. So you see, there is a change in the actual flow rate. In the first set of data, we had 2.85. Now we have 2.46. Now we turn off the pump and we start the calibration process. Flow 0. 0 dp for the valve. Now we have 0 dp for the pump. We need to plug in this 2.46 here. 2.46 here. Then we will turn back on the pump and then we start and then set. Hit start and then set. Okay, you see that there is no data from the pedal wheel. That means we cannot take this data. We need to redo this system. And the calibration was not correct. This time it is okay. And we take a picture. And then we plug in this number in this Excel. So now we plug in the paddle field flow rate 2.59, Venturi flow rate 2.46, and the pump differential pressure we got here 1.66, valve differential pressure 0.84, and the Venturi DP 11.65. We also need to take the power meter reading. So at this setting of the valve position, we get a power consumption of, you already know that it was 21 point, yeah, it came down to 21.1 or 2, yeah, 21.2, 21.2. So that is the power consumption we got. So that's how we take our second set of data. Now we change the valve position to get a power consumption which should be less than the 21.2. So this time we don't need to give 2 turns or 2.5 turns. We may need to give like 1/4 turn or a half turn to get a change in the power consumption. I gave a 1/4 turn. You can see that there is a change in the power consumption, which is right now 20.5. So if we have a power consumption difference of 0.5 or 1 watt, that is perfectly fine. So right now we can consider this one 20.5. So when you have 20.5, we need to take the actual flow rate. Ready? 1, 2, 3. $6.70. I see 850 over 6.70 seconds. 850. And I multiply this with 0.016. That gives me 2.03. Now, the calibration. So I restart the software. I turned off the pump. So we had 2.03. Now turn on the pump. We hit start and then set. Alright, so with my data, let's plug in all those values here. So we have 1.97, 2, 2.05, 1.38, 6.31, and then the power consumption. So to get the power consumption, we need to turn on the pump. So we got 20.5 here. So 20.5. So that gives us third set of data. So to get the fourth set of data, we put back all the water that we collected in third set. Now we need to adjust the valve position. So we had 20.5. Now I adjusted the valve position a little bit, maybe a 1/8 of turn, a full turn. So we got, now I see here 19.8, 19.9. So we can consider that there is a change of the power consumption which is more than 0.5. So it is 19.8 right now. We can consider this one. So now I reset and I start the stopwatch. .47 seconds. Here I got 670 milliliter. 670 milliliter, the actual flow rate. So 670 milliliter over 6.47 seconds. So it is 1.66 gallon per minute. Now we need to calibrate the software. I just turned off the pump. I want to restart the software. Okay, now I make the flow 0. So I'm basically repeating the same process over and over again. So whenever we have a change in the valve position, we have to do the calibration. So we had 1.66 here, 1.66. So now we need to turn on the pump, and then we need to start and finally click the set. Okay. So in paddle wheel I got 1.64, and then I got 1.65 for the Venturi. Pump DP I got 2.17. The valve DP I got 1.69. And the Venturi I got 4.95. And the power meter it is 20.2 right now. All right. Now let's go for the last set of data. So we change the valve position. Okay, actually it is 20.1. I can see here. 0.1. You can change the valve position a little bit so that we can have a change in power consumption. I can see 19.7 right now, 19.6. 19.5. All right, so it is almost 19.4. I think that's okay because we have a difference more than 0.5. So now we need to take the actual flow rate. So as we close the valve, the flow rate goes down. So we need to take the water for a longer time. It's 9.60 seconds right now. And with this time, we have collected water which is about 690. So 690 over 9.6 times our multiplication factor. So that gives us 1.15. All right, so with this 1.15, let's calibrate the software. So what I need to do, you already know, we need to restart the software. We turn off the pump. And then we make this flow 0 dp. Here also we make 0 dp. We plug in 1.15. Now we need to turn on the pump. Hit start and then set. Okay, so I got here 1.09 here. Eventually we got 1.16. Pump dp got 2.48. Valve dp I got 2.15. Eventually I got 2.36. And the power is 19.4 now. 19.4. So this is the data we got for the Venturi, which has a ratio d by d about 0.5. So as you see here, as we close the valve, the actual flow rate, paddle field flow rate and Venturi flow rate goes down. However, as we close the valve, the pump differential pressure and valve differential pressure go up. You see here, the trend is going up. But in case of Venturi dp, we can see that the Venturi differential pressure goes down. Remember that the Venturi dp here is in inches of water column. When you write your report, you need to convert it to PSI. And you can explain why the difference in this differential pressure trend. You see the pump differential pressure and valve differential pressure goes up as we close the valve. However, the Venturi differential pressure goes down. So you can compare, you can explain those things in your report, and that will be a very good understanding between the fluid flow rate and the pressure difference. At this point,